Here we're going to look at limits of functions of two variables. So we recall the process we did in Calculus 1, but this will be a little bit different. So for our first example, we're going to take the limit as xy approaches 1 comma 3 of 2x over x squared plus y squared. Which, what will that be? As the values get very, very close to 1 and 3, what does this function get very, very close to? And the thing to recognize is the bottom is fine. It's 1 squared plus 3 squared if you just plug things in. And the top is 2 times 1. So we get 2 over 10. What enables you to just plug something into a limit to evaluate it? What's the key idea there? Well, it's that the function is continuous. If a function is continuous, then the value of the limit equals the value of the function, and all you've got to do is plug it in. And that's relatively easy. But keep in mind that the real goal is what is happening near the 0.13. If we use a formal delta epsilon definition of a limit, we have some kind of a region around 1,3. We look to see how things are behaving. But let's just take a look at some points near 1,3 to see if they seem to be heading towards 210. So 1,3 gives us 0.2 as expected, but 0.9, 3.1, pretty close to 1,3 gives us 0.172. As I get points closer and closer to 1,3, 1.001, 2.999, notice how close that is to 0.2. Similar with these things. So as we're getting closer and closer to 1,3, the values of the function sure seem to be getting closer and closer to 0.2. And that verifies our notion, indeed, that that limit is 0.2, 2/10. And the reason we could plug that in again is because this function was continuous there. But let's look at a case where it's not continuous. If we plug 0, 0 in for the bottom, we get 0 squared plus 0 squared. 0 is on the bottom and also on the top. But 0, 0 is not in the domain of the function. This function is not continuous, so it is not fair to plug it in to get an answer. So what kind of a strategy can we use? Back in Calc 1, we approached from the left and right. We approached hopefully the same value. If that were the case, we have a limit. We also had a delta epsilon argument you can use. And you certainly can use delta epsilon arguments for this, but my approach here is going to be to approach along different pathways. So let's approach along the line y equals 0. So what does that mean? Where is y equals 0? Well, let's think about it. Y equals 0 is along the x-axis. We're trying to get closer and closer to 0, 0. Y equals 0 is approaching this way. So if we approach that way, what are some of our values going to be? So let's think about points along the x-axis getting closer and closer to 0, 0. What might they be? So here's a few that I'm choosing. Again, y values are always 0, and the x values are getting pretty close to 0. We want to see what are the values of the function at those points. So let's jump to our spreadsheet to see what we get. So what do we notice? If we plug in 0, 0, we get a division by 0 error because it's not in the domain, but all of the other values are 1. Therefore, what? Along that path, the limit appears to be 1. So do we think the limit exists and equals 1? Well, that's a thought. Let's take a look at a second path. So this time I want the x value to be 0. So if I approach along x equals 0, where is that? That is coming along the y-axis. Notice the y values are changing. The x values are all 0. So what does that give me? So looking at the spreadsheet, what are our results? Again, 0, 0, not in the domain, but all of the other ones appear to be -1. So along that path, what do we have? The limit appears to be -1. If two different paths yield two different limits, the conclusion is that the limit does not exist. Now, this is not really a proof. This was just indicated by playing with some numbers near it. So let's go ahead and make the same argument algebraically. So again, conclusion, limit as xy approaches 0, 0 of x squared minus y squared over x squared plus y squared does not exist. So how are we going to be a little bit more formal with this to convince ourselves that indeed that limit does not exist? So to increase the formalism, going along the line y equals 0, what do we have? Well, that becomes the limit x comma 0 because y is 0. Approaches 0, 0 of what? Of x squared minus y squared, 0 squared over x squared plus 0 squared, which becomes the limit. I no longer need two dimensions here. One is good enough. Limit as x goes to 0 of x squared over x squared, which is the limit as x goes to 0 of 1, which equals 1. So that was a more formal approach along that direction. And what if we approach the other way? So along y equals 0, along x equals 0, there will be the limit of 0 comma y approaches 0 comma 0 of what? Of x squared minus, of 0 squared minus y squared over 0 squared plus y squared. Again, I don't need two variables this time. Limit as y goes to 0 of negative y squared over y squared, which is the limit as y goes to 0 of negative 1, which equals negative 1. Since the paths are different, the limit does not exist. All right, let's take a quick look at that function to see if we can get any insight from the visual. So here's our graph. And can we identify what's happening along the x-axis? Can we see what's happening there along the x-axis? That is where y equals 0. Maybe I need to spin this around. So this has more of our standard orientation that we like. Do you see along the x-axis up here that it's coming in at z equals 1? You see that? And along the y-axis this way, it's coming in at z equals negative 1. Now at 0, 0, which I doubt we'll be able to see, there would have to be a hole in the graph. So there's actually nothing happening at 0, 0. It's not part of the domain of that function. So indeed, the two different paths yielded two different limits. Therefore, the limit does not exist. But the warning is, if the two values were the same, that proves nothing. If you have two paths that yield the same limit, that does not mean that the limit exists. So next I want to look at the limit as xy approaches 0, 0 of xy over x squared plus y squared. So before we jump into our algebraic strategies, let's take a quick look at the spreadsheet to see what that indicates. So you'll see what we have here again, 0, 0, not in the domain as expected. We have issues there. But when the x values are 0 and the y values are close to 0, all the results are 0. Similarly, when the y values are 0 and all the x values are close to 0, the results are 0. So it sure seems to be that as we approach from those two sides, we get 0 each time. Can we prove that using algebra? So if I approach along y equals 0, that gives me the limit of x comma 0 approaches 0, 0 of what? The y is 0. So x times 0 over x squared plus 0 squared, which is the limit as x approaches 0 of 0 over x squared, which equals 0 as we were indicated on the spreadsheet. If I go along the line x equals 0, what do I have? I would have the limit of 0 comma y approaches 0, 0 of what? Of 0 times y over 0 squared plus y squared, which is the limit as y goes to 0 of 0 over y squared, which is 0. But we are not finished because that's only two paths. That does not mean that the limit exists. I would have to check an uncountably infinite set of paths to use this kind of strategy. But it just so happens there's a third path I'm interested in looking at. I want to see what happens if we approach along the line y equals x. What's going to happen there? So let's take a look at our spreadsheet to see if that indicates something to us. What do we see? Notice here, all of the values when x and y are the same seem to be giving me 0.5. So can I prove that? If I go along the line y equals x, what would that be? That would be the limit of x comma x approaches 0 comma 0. xy would be the same as x times x. X squared plus y squared would be x squared plus, well, y equals x, another x squared. What does this become? The limit as x approaches 0 of x squared over 2x squared, which is the limit as x approaches 0 of 1/2, which equals 1/2, which agrees with what we saw on the spreadsheet. So we have found different paths yielding different results. So what is our conclusion? The limit as xy approaches 0, 0 of xy over x squared plus y squared does not exist.